Hello, Teacher Alan here. Welcome to our audio presentation, where we delve into the electrifying world of thunder and lightning and explore a fascinating lab demonstration involving a popping plastic balloon. Let's start with the basics. Thunder and lightning are natural phenomena that occur during thunderstorms, which are often accompanied by heavy rain, gusty winds, and dramatic displays of lightning. Lightning is a powerful discharge of electricity in the atmosphere. It's generated within storm clouds through a complex process involving the separation of positive and negative charges. As water droplets and ice particles collide within clouds, they create static electricity, leading to the buildup of electrical charges. When the electrical potential between these charges becomes too great, it creates an electric field. Eventually, this electric field breaks down the air, forming a conductive path for the lightning bolt to travel. Lightning can strike within clouds, between clouds, or from clouds to the ground. Now let's talk about thunder. Thunder is the sound produced by the rapid expansion and contraction of air surrounding a lightning bolt. Lightning is incredibly hot, reaching temperatures of up to 30,000 degrees Celsius or 54 degrees Fahrenheit, which causes the air around it to expand explosively. This rapid expansion generates a shock wave, which we hear as thunder. In our lab demonstration, we'll illustrate the concept of thunder using a simple plastic balloon. As we inflate the balloon, we're essentially building up air pressure inside it. This is like the buildup of electrical charges within a thunder cloud. Now, imagine the balloon as our storm cloud, filled with electrical potential. When the balloon is stretched to its limit or pierced, it's akin to the breakdown of the air in the cloud that creates a conductive path for lightning. As we continue to inflate the balloon, the pressure inside increases, just as the electrical potential within a thundercloud intensifies during a storm. As we release the balloon or pop it with a pin, the sudden release of air pressure causes the stretched material to snap back violently, creating a sharp, loud noise. This demonstration mirrors the process of thunder generation during a lightning strike. Just as the rapid expansion of air creates thunder, the sudden release of built-up air pressure in the balloon creates a loud pop. So, the next time you hear thunder during a storm or the pop of a plastic balloon, remember the electrifying science behind these phenomena. Thank you for joining us for this audio presentation. Stay curious and keep exploring the wonders of nature and science.